In this section, we'll show you how to calibrate your SSR RDOP display to accommodate a number of environmental, situational, or atmospheric conditions. Let's begin this process with a few initial settings. First, select a range scale of 1.5 miles and center your screen. Next, choose a pulse width setting of short-1. Make sure the clutter function is set to manual and the IR mode set to high. Next, position the radar gain to 90% and both the FTC and STC sliders to 0. Once you've established these initial settings, you can fine-tune them individually. Start this fine-tuning process with the sensitivity time constant, or STC. The STC adjusts radar gain as a function of range, amplifying energy from far away and defeating energy in close proximity to your receiver. The proper STC setting helps to eradicate C-clutter generated by waves, which in turn enhances the ease of target detection. To fine-tune the STC, position the slider at 50% and adjust it accordingly to your local conditions, lower for extremely flat days and higher for rougher seas. Next, you'll want to adjust the fast time constant setting. The fast time constant filter, or FTC, contrasts the presence of man-made objects from natural events by identifying the radar return of hard edges and screening out the majority of soft edges consistent with dense rain clouds or sea spray. Again, the ideal setting for individual use will vary depending on region of the world and local weather conditions. To calibrate, position the FTC slider at 20% and increase accordingly. A higher value will reduce interference caused by rain or dense clouds. A lower value would be preferable in clearer weather. Now it's time to set your radar gain. The radar gain acts like the master volume control on a radio. Adjusting this setting higher or lower will either increase or reduce the overall volume of radar returns presented on your monitor. Optimal radar gain settings vary on a number of local conditions. For example, in a very busy harbor, too much radar gain may overwhelm your monitor with data, which can make tracking individual vessels impossible. Conversely, too little radar gain and your screen may not present you with enough information to track smaller vessels effectively. To calibrate your system to local traffic conditions, simply start with a radar gain setting of 90% and reduce gradually until extraneous data is eliminated. The lower the setting, the fewer green dots will appear on your screen. In most situations, a radar gain setting that suppresses the majority of excess noise, yet still depicts the presence of both large and small vessels, is ideal. The SSR radar system also comes equipped with an auto clutter processing module, which calculates an average of data collected from all azimuth sectors and range bins. This can be helpful in a set it and leave it role, although it's best reserved for open sea detection, as vessels close to shore could get masked in the aggregate calculation of land masses in this mode. The final step in calibrating the radar to your needs can be found in the pulse width setting control. This function modulates the actual amount of energy transmitted by the system. A longer pulse width transmits longer and therefore increases the range of your radar. A shorter pulse width transmits less energy, which sacrifices distance but increases the detail of the return image. Use a longer pulse width in environments where incoming vessels need to be recognized at critical distance. Use a shorter pulse width setting when determining whether one larger vessel is in fact two smaller ones. As you can see, SSR makes it easy to fine-tune your radar to a variety of changing conditions or unique situations. To master these settings, we recommend that each radar operator spend a few minutes exploring the control panels covered in this section.